Okay, this meeting is now officially recording. So welcome everyone. So nice to see all your names on the screen. I do see a few faces, so thanks for sharing that with us today. At this point, I don't have any announcements. I'm going to save most of those for the end today. But at this point, I will turn it over to Dave to give us some BWC updates.
Thanks, Sarah. Good morning, everybody. A couple updates. It seems that the Ohio Safety Congress is going to be starting. Registration will start in December, and that is going to be on Wednesday and Thursday of March 9th and 10th of 2022. And some of the areas that they're going to be covering is business strategy, professional development, innovation, and technology, and governance and regulatory. And so it's going to be virtual. I think last year, but they're going to have hopefully more topics that you'll like. So check that out. And then also BWC is also continuing virtual training and webinars. And they just had a session yesterday, field webinar. So what the question would be, so you had a claim, now what? You can go back, it's already recorded, you can go back to the learning management system through BWC and look at that and get credit for that for ISSP. And then also training virtually, they have classes, and the only ones that are remaining for this month is emergency preparedness planning, the half-day workshop, and then health hazards and toxicology fundamentals. And then also hazardous waste operations and emergency response awareness. Through the COVID pandemic, that's certainly something that the BWC has really engaged upon, and they're really exceptional, and I certainly enjoy them. And if you haven't been through them, to look at that, certainly take a look at that. Also, shout out for Jim Clark. Good to see you. Co-worker, industrial hygienist. His last day is going to be in October. He's retiring, and so we'll still continue to have IH services. And if you need anything, to let me know. And I would suspect John McLean, who's also an IH, will pick up the slack since Jim will be out on the boat somewhere fishing. Other than that, that's all I have, Sarah.
All right, thank you, Dave. If you have questions for Dave, feel free to drop those in the chat, or I believe most of you have his email. If not, you can shoot that to me and I can get that passed on and provide that contact information for you as well. Without further ado, today, let's go ahead and we will move into our program. It is my pleasure to introduce our speaker today, who is Alfred Craig of the JDI Group. He's an advocate for electrical safety, and he is passionate about educating industrial clients, building owners, and technical staff on the potential dangers of arc flash event. Alfred brings benchmarking information from hundreds of sites. He has designed and analyzed equipment for many industries: glass, steel, mining, oil and gas, automotive, and other manufacturers. He draws expertise from more than 40 years in the electrical field, starting with time as a journeyman electrician. His areas of expertise include MV, LV substation design, power studies, and arc flash analysis, distribution system remediation, and training. As an NFPA 70E electrical safety training specialist, he leads arc flash study refresh projects and assists clients with assessing risk and maintaining compliance. So welcome, Alfred.
Thank you, Sarah. Let me first say welcome to everybody, and I'll get my screen shared here. I think Karen's going to say a few words before we get going. And let's see if I can, okay. So this is our first screen. I hope everybody can see it.
Yep. All right, well, I will give a quick overview of the JDI Group. I appreciate Sarah, you allowing us the opportunity for Alfred to share his expertise. Just a quick background of the JDI group, and feel free to reach out to us if you have any questions pertaining to all of the subject matter that Alfred will be reviewing. He'd be happy to help you out in any way that we can. The JDI group, we are located in Maumee, Ohio. We are going on our 20th anniversary, and we are a full service architectural engineering and controls firm. We have all disciplines in-house. This allows us to design the site, the building, and the process. We have about 75-ish employees all under one roof, although we do have some people embedded with our clients. And of those employees, about 20 are licensed architects, engineers, and surveyors. We do conceptualize and design in 3D. We do our own 3D scanning and utilize that information in our BIM modeling to help move projects forward and walk our clients through as we move forward and make sure that there's clash detection. If there's any changes necessary, we can make modifications as need be. And we are very excited to be Top Workplace for 7 years now. We do have all services in-house. Here is kind of a list of all of them. Everything from architecture and interior design to all facets of engineering, civil survey, mechanical, both facility and process, structural, electrical, chemical. We have project management as how we run our projects, but it's also a service we provide. We also do automation, instrumentation, controls, MES, data security, AE, AV, and IT managed service contracts. And just as our services are diverse, so too are our markets, and we touch on just about all market sectors. So we welcome the opportunity to connect you with our technical team, whatever questions you may have. We are happy to have a conversation and provide expert advice and recommendations where needed, just to help uncover projects and help you move things forward.
Okay,
Turn it over to Alfred.
Thank you, Karen. Again, welcome to all. We believe that the workplace shouldn't be a dangerous place to be. And, I have as mentioned, a passion for this area of safety related to workplaces. And that's got to do with the arc flash hazards that exist in most, if not all, workplaces. We're going to be talking, explaining a little bit about the arc flash hazard itself, the dangerous event and the characteristics of it. We're going to be talking about the injuries caused by arc flash events, codes and standards related to this subject matter, of which the NFPA 70E that has just scrolled up on the screen on the right, this is the Bible for electrical safety across the country, actually. We'll talk about arc flash prevention and PPE, very important things for all employers to know a lot about. Unfortunately, there is a lot of misinformation out there. And a lot of workplaces are behind the 8 ball in this subject matter. We'll talk about how it is required by law for those. That's a very common question that I get. So I'll answer that question. We'll talk about the bid process for electrical upgrades and equipment installation. So very often, the subject matter of electrical safety is overlooked in the bid process. So if that's not thought out and presented in the appropriate way, at least a minimal way in the bid process, then the results can be pretty disastrous in terms of the final design results and the dangerous conditions that might be presented on new equipment that's installed because it wasn't thought of ahead of time. Okay, so the definition of an arc flash hazard: a dangerous condition associated with the release of energy caused by an electric arc. Extreme characteristics in these events, pretty common. We're moving the trajectory in this area ever so slowly across the country. This is an example of one captured on a surveillance video, a little bit grainy, but it definitely will give you an idea of what arc flash is, how bad an event can be. You'll see the event occur here, and notice that the worker is not wearing an arc flash suit, which would be required if this had been thought out by the employer. Couple of things to notice about this video. I'll replay it at least once. Okay, let's try that again. Yeah, you'll notice that the lights all go out. Okay, so an important item that many, if not I could say most employers don't think about is emergency lighting in substation areas. So, the question that comes to mind looking at that video is, okay, how did those guys escape? How did they crawl out of that room that got filled with toxic fumes? So if they didn't get burned, there's no natural light in that room. So how did they escape? Okay, so this next short video is useful to look at for its record of an event where there's high-speed photography involved. And unless that is incorporated, it's difficult to see just how dangerous these events are.
This is a 30 amp disconnect, and the arc is going to be calculated to be well below 4 calories, safe at 18 inches. However, even though that might not look like much, when we look at it again in slow motion, what you clearly see is a violent arc that rockets out of that box and goes 6 or 7 feet away. You're clearly not safe in this incident 18 inches from the arc gap because of the projection of the energy. We'll get an outstanding look at that in the frame by frame. Here comes the arc, and within the first couple of frames, it's 3 feet out of the box. Again, you're not safe at 18 inches. The arc continues to grow. It projects out 6 feet and begins to put out a massive amount of molten metal, which presents its own hazard, molten metal being in the neighborhood of 1900 degrees Fahrenheit and non-FR cotton igniting at less than 800.
So that actually gives you an event a record of an event where you can actually see just how dangerous that is. So arc flash facts: electric arc is a short circuit through the air. So the way to think about it is you have all these, electrical systems with lots of energy, just waiting to expend itself somewhere, anywhere. Basically, a small circuit from any phase to ground or phase to phase can initiate an arc flash event. And in industry, the systems are so powerful that an electric arc is struck and will expend itself until the circuit is opened upstream. So electric arc is a short circuit through the air. Okay, so ridiculously high temperatures. The events that we just watched were somewhere in the neighborhood of 20 to 35,000 degrees Fahrenheit. The sun is 10,000 degrees Fahrenheit, the surface of the sun, to give you an idea just how hot that is, and so very dangerous. So that will burn the skin directly, cause ignition of clothing, which adds to the burn injury. So you can see that PPE and electrical workers need to be, teamed up here. Okay, majority of hospital admissions due to electrical accidents are from arc/burns, not from shocks. Each year, more than 2,000 people are admitted to burn centers with severe arc/burns. Okay, so arc flash intensity. So how do we measure this very, very dangerous condition? We measure it in calories per centimeter squared. Simply calories when we're talking about arc flash. 1.2 calories. It's a very important number. It's enough energy to cause a second-degree burn on human skin. And those of us that specialize in this area, that 1.2 is a very important threshold. And the way we look at it in terms of injury is if it's less than 1.2 calories, it's approximating a Band-Aid event, an event where someone might go to the hospital, but they probably won't be admitted. And over 1.2 calories, it quickly becomes dangerous enough that a person would need to be transported to a burn center, a specialized medical facility to treat terrible arc flash burns. So 10 to 30 calories is not uncommon on sites. And, for those who want to know a little bit more, these calories are measured at typically 18 inches from the live parts. So, in the video, you might have heard 18 inches mentioned. That's considered to be the working distance, and that's where we measure the calories. So 18 inches from live parts. Industrial substations can produce energies well above 75 calories. So once you get up to this high of a level of calories, very, very dangerous, large fireballs. The first video in the substation was something less than 75 calories typically. So you can imagine 75 is quite an event. Okay, so what causes arc flash events? Okay, so how can we just not cause it? Well, dropping parts or tools. We're going to go through this list, but keep in mind that the bottom line is you might just be in the wrong place at the wrong time. It could be that the equipment is prone to arc flash events due to reasons out of your control. So accidental contact with live circuits, of course, equipment failure or misuse, poor maintenance, that should ring a bell for most of us because many sites, many facilities don't put a lot of emphasis on maintenance. Buildup of dust, corrosion, moisture, that should ring a bell because it's all over the place in industry, especially the older industries. Operation of old equipment. So, power, industrial equipment to distribute power in facilities, say, that have large motors in service. They're going to be big, powerful pieces of equipment that's meant to switch very high energies. And with that comes very high calories in the arc flash events when they occur. Okay, so what are the results of an arc flash event? These are typical and normally involve all of this list. So personnel can be injured very badly. Okay, so that should be the top of our concern, keeping our people safe, making sure they go home every day. safely and without harm. Equipment can be destroyed, very expensive. You know, when these events occur and equipment is destroyed, you know, very costly events follow. You know, you might need to buy equipment that is manufactured in another state, in another country. Production losses, so it interrupts everything, you know, related to the power system that where power is lost. Portable emergency power may be needed. So I have seen events, I've worked in facilities where this was required. And, you know, believe me, having a large generator running 24/7 in a parking lot is very costly, just in fuel, let alone the lease cost for the generating equipment, the time it takes to get there and mobilize it. Installing new equipment in an emergency time frame, 2, 3, 4 times the cost of a normal acquisition. Absolutely. Liability costs to injured workers. So these days, burn center incident can cost a company upwards of 10 to 15 million. A fatality, 20 to 25 million. So, you know, the very, very large companies can, grapple with that, and some companies cannot. Okay, so arc flash burn injuries, 1st to 4th degree. Okay, 1st degree affects outer layer of skin. It's like a really bad sunburn, say. 2nd degree burn is tissue damage, blistering. You're getting into a very dangerous condition here. And then 3rd degree, complete destruction of skin. Skin grafting will be required. Burn center level burns. 4th degree affects all layers of skin and also structures below the skin. So 4th degree, we typically see that in utility accidents where the voltage and or power are extreme levels, where most industry, the burn injuries are 2nd and 3rd degree. Okay, so 2nd, 3rd, and 4th degree burns break the skin, provide a pathway for infection. Most hospital deaths 2 to 4 weeks after the arc flash event are from infection. They call it septic shock. So, you know, a person can walk away from an incident like that with terrible burns and be taken care of in a burn center, but then expire several weeks later due to infection. As a graphical representation, is basically if you take away the epidermis and dermis skin layers, then you're susceptible, very highly susceptible to infection and septic shock. Okay, codes and standards. Something we all, I'm sure, like to read and look at, but in any case, the 1584, this one on the left up here, this is where the equations come from for the analysis and calculations in arc flash. Over to the right, you got your National Electrical Code. This is how, you know, guides contractors how to install equipment. And the NFPA 70B over here, that is a roadmap for maintenance managers on how they maintain equipment and keep it in good working order. Now, the bottom row is electrical safety and all things arc flash. You got the NFPA 70E, like I mentioned before, it's the Bible. It's packed with information. We would recommend that any and all workplaces have a copy of this on site. And then to the right are the two CFRs related to electrical safety from the folks at OSHA. Okay, so a lot of times we get a question, okay, hey, is it required by law to deal with this arc flash stuff? Well, it always has been, really. The OSHA General Duty Clause, which was authored back in 1970, states, you know, black and white, each employer shall furnish to each of his employees employment and a place of employment which are free from recognized hazards that are causing or are likely to cause death or serious physical harm to his employees. That's straight out of the OSHA articles. And if that wasn't enough, okay, in 2015, an article was added to the 1910.269 area in the OSHA regulation. For each employee exposed to hazards from electric arcs, the employer shall make a reasonable estimate of the incident heat energy to which the employee would be exposed. So it's very clear. There is no hiding from this. It is a requirement. So what do we do about it? Where do we start? I mean, for companies that don't know anything about arc flash, the first thing is to get information. You know, so we would recommend all companies, large and small, appoint an electrical safety champion. Okay, someone that can look at this subject matter and make some choices, make decisions, suggest a plan, perform a study, remediate elevated energies. So you do an arc flash study to find out how much energy is on your equipment. Apply warning labels to equipment. So after the study, you put a label on each piece of equipment where it's likely or a requirement for your workers to access live parts. Okay, that's what it comes down to. It's all about when a worker is exposed to live energized parts. Create an electrical safety program. So that's basically the running rules for electrical workers on site. Clarify your PPE policies to all employees. Crucial. If you do nothing else to get going in this area, employers should have PPE on site and tell their employees when and how to use it. So even if you don't have labels on the site, there can be policy of an incident. Train electrical and non-electrical workers. So the electrical workers are the ones that receive the most training, of course. Specify for safety in the bid process. So we'll talk a little bit about that. I had mentioned it earlier on also. This is an example of a label on a piece of equipment. And you know, the data on this label would be explained to the employees in training so that they know the prescription for PPE if they were to open that door and the equipment was live. Okay, so equipment labeling goes from the lowest levels of arc flash energy that is calculated to the highest levels. Okay, the bottom level is if the calories are less than 1.2. So this is an example label that we currently use for one of our clients. And basically If the calories are low enough, a face shield is not necessary. A full body arc flash suit is not necessary. Basically, long pants, long shirt sleeves, non-melting natural fiber, and protection for your hands. Okay, so then as you work up through the ladder of incident energy and a scale of dangerousness, you could say, the PPE gets to be more. So this threshold is 8 calories. So if it's above 1.2 calories and less than 8 calories, the workers would be guided to wear arc-rated clothing, hand protection, a shield and balaclava. Because, at calories, at this level of calorie, the fireball can surround a worker's head. So a balaclava is added was added about 6 years ago to protect the neck of the electrical worker. Okay, so when it gets to be above 8 calories, but less than 40 calories, a full arc flash suit is required. For example, let's look at this label just briefly. Arc flash protection boundary, 69 inches. That's the 1.2 calorie threshold, and I don't want to get buried in too much detail here, but I thought we should mention that at least. The arc flash protection boundary is where there exists 1.2 calories, enough to cause a second-degree burn on human skin. So 70 inches away from that live part, those live parts, if an arc flash event were to occur, it would be potentially a second-degree burn. Well, of course, you're not going to be 70 inches away from live parts. If you open an access cover or door and you're working in live parts with these calorie levels, you need a suit on. And most companies across the country, when you cross the threshold above 40 calories, they just tell their workers, energized work is not permitted on this equipment. Look at the calories here, 84, 85 calories here. Arc flash protection boundary, 189 inches. So that distance away from the live parts, the worker could receive a second-degree burn if exposed. Scary. Okay, so specify for safety. Bid documents, requests for quotations often do not take into account arc flash concerns. The vast majority. Electrical upgrades and equipment installation often are bid with a very general request for quotation. Competitive pressure force companies to exclude anything that is not explicitly requested. So bottom line, if you don't ask for something to be included in a contract, it will not be. Okay, so what happens if the bid documents are not detailed and we do not request deliverables related to arc flash? No pre-engineering to determine arc flash performance. Okay, that's a problem because it's far easier to remediate arc flash before the equipment is purchased. Sometimes it doesn't cost any more. Sometimes just buying a different piece of equipment will make the equipment safer. No warning label deliverable. So if you don't ask that the arc flash analysis be done and that the consultant or contractor apply labels when they're done the installation, it won't be done. And it usually results in dangerously high arc flash energies. The way equipment was built and installed decades ago is in some ways maintained today. So you have to, design, install, build differently for arc flash in order to remediate it. Okay, so we would say use a consultant to create a custom specification for the project that includes arc flash mitigation and arc flash warning labels. Basically, I'm not a salesman. I have to say that. Of course we want you to use JDI, but use somebody to create a custom specification for the project. Take care of this. Realize better designs, safer designs, lower costs. Sometimes it's a drastically lower cost and a design that offers full remediation of arc flash. Okay, I have a few more things to present, but I'd like to take some questions if there was some out there. I'll pull up the chat log to see if something comes in there. And after talking this much for this long, I'm kind of hoping that everyone heard me because I never got a confirmation.
I would love to know from the Safety Council if you are currently incorporating arc flash when you are putting out RFQs. Is that something that you focus on or not? So if anyone would like to share any information, that would be wonderful.
Feel free to unmute, or you can put it in the chat box as well.
Yeah, while we're waiting, or possibly for someone to enter a question in the chat log, this is a handout that we've produced for those who wish to know more about how to comply with the regulations. If anybody would like this, I can send it to them directly. JDI is pretty good about consulting with clients, even possible clients, just as a courtesy. I mean, if you have questions or you'd like to talk about this subject matter specifically, I can be reached anytime. But all areas of engineering, most consulting firms, offer, free consultations as a courtesy. We do a good job there. Okay, one question came in. Would the label have to be updated when a machine gets moved or updated? Yes, but it's moved within the facility. It doesn't necessarily mean that the energies are going to be drastically different, but yeah, it would have to be updated. So just let me back up. When an arc flash analysis is done by almost anybody, data is collected on the site, a model is built in a computer application, and when a piece of equipment were moved, that would be moved in the model. The studies would be rerun, and the labels would be printed off, the updated labels. Okay, so I got something here. The screen is blank, just navy blue. Should it be? Can everybody see the PDF or can anybody see the PDF?
No, it's just like a gray screen.
I wonder why. Okay, let me see what I can do about that. Okay. Okay, let's try that.
Now we see it.
Okay, so this is the flow chart that I offered up before. Anybody would like this? We created this a few years ago, and it hasn't had to be updated. It's still accurate, and it's a roadmap for anybody that would like to know how to comply with the regulations. It's good. I've not seen anything similar to it out in the, on the internet or with other companies that we interface with. Okay, I'll bring another screen up here while we're still discussing. Or I will try to.
For some reason, we still see the flowchart PDF, but your screen gray boxes keep popping up, and now we have one large gray box.
Okay. Okay. Sorry about that.
That's okay.
Okay.
Now we
you
can
should see my browser now.
Yes.
Okay. So the NFPA, for those who weren't aware of it, you can go to the NFPA site and create an account and look at all their publications. And there's several hundred that your average industrial company would have a reason to have access to. But there's also a thing called the NFPA link. And why I bring that up is, and we have no commercial connection to NFPA at all, but for an individual, for $10 a month, you can have access to all of the standards online. It's just an excellent way to have the standards at your fingertips. Okay. Now, can you, did the screen change for you all? Now I'm showing a bunch of just different standards.
Yes, we see that.
Yeah, so the NFPA is trying to add all of their standards. And I think they're up to about 100 now. So it's just simply a bargain to do it that way. Oops. That's not the one.
There, now we're back to that same page. There you go.
Okay. Yeah, so I'll just offer that up again. Anybody would like to know more about arc flash, electrical safety, we're open to have that conversation with anybody.
Okay. Well, thank you so much. We greatly appreciate your presentation. If needed and you didn't get it today during the presentation, I can provide you with contact information for the JDI group. We'll also put that in our next newsletter, as well as a link to this presentation, so you can go back and rewatch it or pick up anything that you missed. All right, so just a couple of announcements moving forward for the October Safety Council. meeting. If you recall, the October meeting is a mega meeting with the Ohio BWC. So it will not be on our regular third Wednesday of every month. It will actually take place on October 6th, and the meeting will run 11 to noon, and it will be Leading from Your Heart by David Sarkis. And a welcome to the group will be given by BWC Administrator Stephanie Cloud. So please make sure you change that date in all of your calendars, because that October 6th meeting will take the place of our regularly scheduled meeting. If you have any questions in the meantime, please don't hesitate to reach out and let me know. And I will put all of this in an email and get all of these updates and all this information out to the group as well. All right, so last chance for questions, comments for me or for Alfred or for Karen. All right, we have a very quiet group today. All right, well, thank you all, everyone. Have a fabulous day and stay safe out there. Thanks so much.
Same to you.
Thanks, Sarah. Thanks,
Thanks
everyone.
for the invitation. Thanks all.